Okay, so in this video, we will consider additional problems of implicit differentiation. So here's a problem. We're given a curve, and here's its equation. So x cubed minus xy squared plus 5y equals 1. And we want to find the equation of the tangent line to this curve at the point x equals 2, y equals negative 1. And again, when you give an equation for a curve, what that means is that the points on the curve are the solutions to this equation. If you wanted, and it's not clear what this curve may look like, if you plot all the points, so all values of x and y that satisfy this equation, it's not clear what the curve may look like. So for example, if you wanted to visualize this curve in the xy plane, you could use Maple, and Maple could actually show you a very accurate sketch of what this curve may look like in the xy plane. But for us, we don't need to actually visualize the curve. We need to find the equation of the tangent line at a point. All we need is the derivative, and hence using implicit differentiation. Let's verify first that this point indeed is a point on our curve. So this point will be a point on the curve if the point is a solution to the equation of the curve. So if we replace x by 2 and y by negative 1 in the equation should be satisfied. So let's see. 2 cubed is 8, minus 2 times negative 1 squared is plus 1. So we get 8 minus 2 is 6, plus 5 times... Sorry about that. So we get 8 minus 2 is 6, plus 5 times negative 1, 6 minus 5 is 1. So you see that this point satisfies this equation, therefore this point is indeed a point on the curve. Alright, so we need a derivative. Let's use implicit differentiation. We do not have to solve for y in terms of x. We can do better using our method of implicit differentiation. As before, we think of x being the independent variable, and we think of y being a function of x. Well, both sides are equal, so they must have the same derivative. So the derivative of the left-hand side, x cubed, minus xy squared plus 5y, and that's the derivative of the left-hand side. This should equal the derivative of the right-hand side, right? Both sides are equal as functions of x because we think of y as a function of x. Even though we don't know what it is, we can still think of y as a function of x. Both sides are equal, hence they have the same derivative with respect to x. Let's differentiate both sides carefully now. So the derivative of x cubed with respect to x is simply 3x squared. So that's taking care of x cubed minus the derivative now of x times y squared. Open parentheses, what goes here now is the derivative of x times y squared. Here we have to use the product rule. Alright, so the product rule says to differentiate the product of two functions, it is the derivative of the first function. So if you differentiate x with respect to x, you get 1. Derivative of the first function times the second function, y squared. And then plus, and now we flip the role of the derivative, plus the first function, x, times the derivative of the second function. And here we have to be careful. We differentiate y squared with respect to x. And y is a function of x. We have to use a chain rule. First differentiate the power 2, and you get 2y. The chain rule says we have to multiply what we have so far by the derivative of what's left over. What's left over is y, so that's times the derivative of y with respect to x. And that takes care of the derivative of this part, so we close the parenthesis. Plus the derivative of this function, well, 5 is a constant multiple, so it stays there, times the derivative of y with respect to x. Again, that simply is dy over dx. And that equals the derivative of 1 with respect to x, 1 is a constant, the derivative of a constant is equal to 0. Now we have differentiated, and if you look, there's a dy over dx here and a dy over dx here. So we have to regroup. Well, let's distribute the negative sign over the sum of two terms. So we get that 3x squared minus y squared minus 2xy times the derivative of y with respect to x plus 5 times the derivative of y with respect to x. This is equal to 0. Well, if we want to isolate for dy over dx, we have to put them on the same side of the equality. So here you could send both of these on the right-hand side, or send both of these on the right-hand side. We'll send these two terms on the right-hand side. So what we'll have then will be that 3x squared minus y squared on the left side will be equal to, if you send negative 2xy dy over dx on the right, it becomes a positive. So it's positive 2xy dy over dx. This term will become negative 5 dy over dx. And now we have isolated every term that is multiplied by dy over dx on one side of the equation. We can now factor dy over dx from the right-hand side. So what we have is 3x squared minus y squared is equal to dy over dx, so we factor it, times, well, if you factor it from this term, you're left with 2xy, minus, if you factor it from this term now, you're left with negative 5. And now you have that 3x squared minus y squared is the derivative times this term. Well, divide both sides by this, and you'll have isolated the derivative. So our conclusion is that dy over dx is equal to the left-hand side, so 3x squared minus y squared divided by 2xy minus 5. And we have the derivative of our curve. At any given value of x, y, so for any point on the curve, the slope of the curve is given by 3x squared minus y squared over 2xy minus 5. Now that we have the derivative, we can go back and find the equation of the tangent line at the point x equals 2, y equals negative 1, right? So the tangent line is given by the equation y equals mx plus b. It simply is a line. And our point was x2, y negative 1. As always, the slope of the tangent line is the derivative. So let's find our slope first. So m, the slope of the tangent line, is the derivative of the curve, specifically at the point of interest. The point of interest here is x equals 2, y equals negative 1. So let's replace. The derivative is this equation, so it's 3x squared minus y squared over 2xy minus 5 at when x is 2 and when y is equal to negative 1. And now we just replace. So what do we have on top? 3 times x squared, but x is 2. 2 squared is 4. 3 times 4 is 12. So 12 minus y squared. Y is negative 1. If you square negative 1, you get positive 1. So negative 1 over 2 times xy. Well, x times y is negative 2. 2 times negative 2 is negative 4 minus 5. So we're left with on top 11 over negative 9, which is simply negative 11 over 9. So now we have the slope of our tangent line, right? Y is equal to m, negative 11 over 9, x plus b. And as always, we can solve for b using the fact that the tangent line passes through this point. Therefore, that this point satisfies the equation of the tangent line. So let's substitute. Y is negative 1. So negative 1 is equal to negative 11 over 9 times x, which is 2, plus b. But that's negative 22 over 9 plus b, and that's equal to negative 1. So if you want to solve for b, add 22 over 9 on both sides. So b is negative 1 plus 22 over 9. Common denominator, negative 1 is negative 9 over 9 plus 22 over 9. 22 minus 9 is 13. So that's 13 over 9. And now we have the equation of our tangent line. Y is mx plus b, m, negative 11 over 9, plus b, which we've just found to be equal to 13 over 9. And there you have it. We have the equation of the tangent line to the curve given by this equation, specifically at the point x equals 2, y equals negative 1.